So in this video, we are going to create a simple character controller for our player to move and jump and double jump. So first, let's create a Unity project, and let's name it Setup 3D Character. Character. So after our project is open, let's create a simple scene with a floor. Let's import a plane object, and if it's not resetted, let's reset its position. Let's name it as floor, and we are going to create a material for our floor object, and we will name it as floor. So I use this naming convention to separate between different file types. So let's select the color of blue like this, and let's drag and drop to the floor. And also let's create a player, which is a capsule, 3D capsule, and we'll name it as player. So all right, let's create another material for our player, and let's also create a materials folder to group them. And let's create another material for our player, and let's choose an albedo color of red, and we can also drag this to our player, and let's also give a Y value of 1, and if it's not resetted, you should reset it before you do that also. So let's give a value of 1 so that it will stay on the floor, and let's make it closer the camera. We can rotate a little bit, and yeah, that's good. That seems good. All right, now we are going to create a character controller, which will be a script. But first, we're going to need to add a character controller component to our player. So if you click Add Component and search for character controller, you can add it. There are some properties here. These are to be used in our movement script. We won't be using any of them. We will only create a gravity, and we will use the move function of character controller. So one thing to mention, the character controller comes with a capsule collider, so that you can delete the existing one because you don't need them. And if you have another character, you can adjust the height and radius based on your character. So let's create a script to program our movements. Let's create a C# script named player, and we're going to attach it. You can just click the script and drag it to our player, and it will be attached. So double click on the script, and I'm using Visual Studio Code because I'm used to this editor, but if you're using Visual Studio, that's totally fine. So we're going to reference the character controller from our player game object. So in the start of the script, we are going to reference to the character controller component from our player, which is here. So yeah, to move our character, what do we need? We need both horizontal movements, horizontal input, which will get it from the input.getAxis method, and we also need the vertical input. So we're going to use the controller's move method, and we are going to, as you can see, this method takes n vector free parameter, and we are going to feed our horizontal and vertical inputs as x and z values. So let's create a local variable for that. Let's create a vector free direction variable, and let's assign to a vector free object, and for the x we're going to give horizontal input, and for the z we're going to give the vertical input, and in here we are going to pass this direction. So let's save it and return to Unity. If you open the file and if you open the game and test it, you see we can move, but the movement happens very quickly, and this is because this update runs once per frame, and frames per second can vary depending on your hardware. So to overcome this issue, to make this calculation happen once per second, we are going to use multiply this direction value with time dot delta time. And if you save it and return to Unity now, you can see our player can move better, smoother now. So we also need a speed variable so that we can control the speed of our player. Let's create a float variable named move speed, and we can give 5f as a default value. Now we want to make this visible in the inspector, so we are going to make it serializable. We do this because this is a private variable. This is encapsulated inside the script, so other scripts cannot reach it and change its value. But we want to see it in the inspector, right? So that's why we are making it serializable, but it's still not reachable by the other scripts. So this is the main difference by doing this public, because this way other scripts can also reach to this variable and change it. So yeah, what we're going to do with this move speed variable is that we are going to multiply our direction with this move speed. And if we return to Unity now, and you're going to see our speed will pop up, and now our speed is applying, and we can change it in the runtime here. You can make it slow, and if you notice, you can also make it negative, and that will change make the directions opposite way. So now that we don't use any physics to move our character, we are going to need a gravity functionality to make the character fall off of any plane, because right now you see it doesn't fall off, it just floats on the air. So for that reason, we are going to implement our own gravity functionality, and this is just simple as subtracting a gravity value from the direction's y value. So what do we have? We have a gravity, and what do we want to do with it? We want to subtract our direction y in each frame. So that way we are going to have a simple gravity functionality. And as you can see, yeah, right now our player can fall off. So now that we have gravity, we can also have a jumping functionality, right? So what is the first requirement to have a jump functionality is to get an input, right? If the jump button is pressed, then we are going to give the direction Y a value, and we can create a jump speed value for it, and let's have a default value of 3.5, and we're going to assign this to our jump speed. And now let's see what happens. Let's play this, and as you can see, our jump speed is pop up. Let's play this, and nothing happens. So let's play here a little bit, and let's increase this a lot. And as you see, it actually happens, but there's a bug in our code. So let's examine what we are doing here. We are initializing a direction value, direction vector 3, with a y value of 0. Yeah. So after that, if we have pressed the jump button, we give the jump speed value to our y, and then we subtract our gravity. Now, and then we move. Now what happens in the next frame? We are reinitialize this direction, and our y value is 0. So it doesn't remember the previous value from our direction y. So if we somehow store this direction y in a temporary, let's say direction y in a temporary value variable here, direction y, and after these calculations, if we reset it, if we say the direction y is this temporary value, then this won't be reinitialized to 0 in each frame. Instead, it will be remembered. The previous value of direction y will be always remembered and stored in this value. So it stayed in the game mode. Let's start the game again. Let's test it now. So we don't jump again. Let's increase jump speed. So nothing happens again. So maybe if we lower the gravity a little bit, or a little bit, and jump speed, let's increase the jump speed, we can get, maybe a lower jump speed is better. So the falling off happens too quick. I think it is the same reason in the start where we move too quickly. If we multiply it with time, if you multiply this calculation with time delta time, maybe it will happen much smoother. So let's test it. And I think this jump speed value is too much right now. Maybe 2. Yeah, it floats because gravity is too low. Let's reset it to these values, and now we have a smoother jumping, right? But another issue is that we can jump infinitely. So let's solve this. What do we need to check? Whether we are on the ground or not, right? So rather than creating a temporary value, a Boolean value, we can use the controller's isGrounded property, and this will give us whether our player collides with any floor or not. Well, actually, whether it is colliding with another collider, because in Unity there is not a concept, or in 3D there is not a concept of floor. Floor has a mesh collider, and player also has a capsule collider, and if two of them collides, then its grounded value here will return to true. So let's check this. So we said if we are on the ground, we can jump. Let's test this. And now, as you can see, we can only jump once. But what if I want to double jump? So for that, the requirements are what? We don't have to be on the ground. Yeah. So we don't have to be on the ground, but we still need to press the jump button. But this time, we also want to check whether we did with it double jump or not. So for that, we are going to create a Boolean value that says can double jump, and let's reset this or give an initial value of false. So when can this be true? When can be double jump? If we are on the ground, that means in the future when we jump, we can also double jump. And in here, we can do the same calculation here. And also, what I like to do is to have another serializable field named double jump. Name double jump multiplier. All right. Let's give a value of 0.5, and I want to multiply this jump speed with my double jump multiplier. And when I did double jump, when I performed the double jump action, I can now say that I can't double jump anymore. And also, not to forget to include this condition in our if statement here. So let's add it. So if we press the jump button and we can double jump, then we double jump. Easy as that. So let's return to Unity again and play our script. And yeah, just like this. You can play with these values and however you want. You can, give 0.8, which I actually like better. Yeah, like this. You can also maximize it. So yeah, this is the basic functionality for a character controller. In the next videos, we are going to add camera to the scene, and also we are going to import a 3D character in the later videos. So see you in the later videos. Bye.